Okay, this is the second part of the 5.5 notes. See part 1 if you haven't already looked at that yet. So, this time we want to find the real zeros of 2x to the 4th plus 13x cubed plus 29x squared plus 29x plus 9. So, let's go through the steps as always. So, first things first. It's degree 4. Which means that the maximum number of real roots, that's a number sign, good golly, sorry y'all. Maximum number of real roots is 4. Okay, second thing, Descartes' rule of signs. So in f of x, we have 0 sign changes because everything's positive, right? So no sign changes in f of x means 0 positive real roots. Well, this is good. This cuts down our things we have to test by 50%. Because we can throw out all the positive ones. Okay, let's look at f of negative x. Okay, you guys can work this out yourself. I'm going to go through it quickly. So we have 2x to the 4th minus 13x cubed plus 29x squared minus 27x plus 9. So that gives us 1, 2, 3, 4 sign changes. 4 sign changes in f of negative x, which means we have either 4, 2, or 0 negative real roots. So now we have to do our P over Q's. So P over Q. Well, let's see. For P's, we got plus minus 1, plus minus 3, and plus minus 9. And for Q, we have plus minus 1 and plus minus 2. So that means P's over Q's, we have plus minus 1, plus minus 3, plus minus 9, plus minus 1/2, plus minus 3/2, and plus or minus 9/2. Now remember, we do not have to test any of those positive numbers because from Descartes' rule of signs, we know that we have 0 positive real roots. So we only need to test the negative ones. So let's start with negative 1. F of negative 1, so if I put negative 1 in for x in the function, I get 0. So let's do synthetic division with negative 1. So we've got 2, 13, 29, 27, and 9. Okay, so we bring the 2 down, we multiply, we add, we multiply, we add, oops, we multiply, we add, we multiply, and we get a remainder of 0. Okay, so unfortunately, since we started with a polynomial of degree 4, what we have now, our depressed equation, is a degree 3. So we might as well try another one. So if I plug -3 back in, and I don't have to plug it into the original, I can plug it into, let's call what we have now g of x. So g of x is 2x cubed plus 11x squared plus 18x plus 9. So let's try plugging -3 into that. When I do, I get 0. That's good. That means I can plug -3 in, and I don't have to do synthetic division on the original. In fact, I don't want to. It's better to do it on the depressed equation. So I'm going to write g of x here and just do my synthetic division. So 2, -6, add is 5, multiply -15, add is 3, multiply is -9, and I get a remainder of 0. Which leaves me with a new depressed equation of 2x squared plus 5x plus 3. And we're going to set that equal to 0, and this one factors, so I'm going to factor it. So that gives me 2x plus 3 times x plus 1 equals 0. And so 2x plus 3 equals 0, or x plus 1 equals 0. So x equals -3 halves from the first equation, or x equals -1. So that's good. If we write them all, we have x equals -1, -3, that's from the two where we did the synthetic division, and then from where we factored, -3 halves, and oh look, -1 again. Well, we don't have to write -1 again because we already have it once. So what does that mean about -1? It means that its multiplicity is 2, because we got it twice. Okay, now let's use the zeros we just got to factor f of x. So to factor this, we would have f of x equals, okay, remember, whatever the root is, we have to change the sign for when we make the factors, right? So the root of -1 gives us a factor of x plus 1. And remember, since it came up twice, that means it's squared. Times x plus 3. And then the last one is x plus 2/3. Now, sometimes they don't like you to have a fraction. If that happens, you can just change this last piece so that it looks like this. 3x plus 2. So whatever the denominator is, you multiply it by the x, and then just leave the numerator alone. So you can write it either one of those ways, and I'm not sure how Pearson wants it, but we all know Pearson's picky, so if you try one and Pearson doesn't like it, try the other. Alright, moving to the next page. We have another theorem. And this theorem says that every polynomial with real coefficients can be uniquely factored into a product of linear, which is first term, or first degree, sorry, factors, and irreducible quadratic factors. Irreducible means it's a quadratic that can't be factored. Hopefully I can stick quadratic in here. Quadratic. Okay, and then another theorem says that a polynomial function with real coefficients of odd degree has at least one real zero. And that makes sense, right? Because remember, those odd degree ones look something like this, more or less, which means that somewhere it crosses the axis once. It may cross more than once, but it has to cross at least once. Okay, so let's find the real solutions to this. So it's degree 4, so there are 4 possible roots. In f of x, we have 1, 2, 3, okay, 3 sign changes, so that means we have 3 or 1 positive real roots. Okay, f of negative x is x to the 4th plus x cubed plus 2x squared plus 4x minus 8. So that means we have 1 sign change, so there's only 1 possible negative real root. So let's find our p's and q's. So the p's are factors of 8, so we got plus minus 1, plus minus 2, plus minus 4, and plus minus 8. And since our q's are just factors of plus minus 1, we're done. So now let's start testing. Let's see. F of 1, if we plug 1 in for x in the original equation, not in f of negative x, but f of x, we get negative 10. Okay, so positive 1 is not a root. What about negative 1? F of negative 1 gives us 0. So negative 1's a root, so again, we're down to synthetic division. So we got 1, negative 1, 2, negative 4, and 8. And if we do our division, we have 1, multiply, add, multiply, add, multiply, add, that should be a minus 8, multiply, and add, so we get a denominator of 0. So our depressed equation is x cubed minus 2x squared plus 4x minus 8. So we can start plugging into that. So we'll call it G, just because. So G of positive 2 gives us 0. So let's do synthetic division again. And we can actually just do it right from where we were and not have to rewrite stuff. So now when we do this synthetic division this time, we're going to ignore our remainder of 0 from the last time. So 1 and multiply, add, and multiply, add, multiply, add. So what are we left with this time? Well, let's call this depressed equation h of x, and it is x squared plus 4. So x squared plus 4 does not factor. So you can see if we were to write f of x as its factors, we would have x plus 1 from the negative 1, x minus 2 from the positive 2 root, and we're left with an irreducible quadratic that does not factor. So what we discovered is we have one negative root. So negative 1 is a negative root, right? Negative real root. Positive 2 is a positive real root. And this quadratic that's irreducible will give us 2 complex roots. So we still have 4 total roots, but only 2 of them are real and 2 of them are complex. Okay, moving on to the next page. And this is the last one. Yay! Okay, the last problem. If I can, there we go. Lost my cursor again. So, we're going to factor this over the real numbers. So, since all we want to do is factor, let's just, I guess, do it like we always do. So, sign changes in f of x. 1, 2. 2 sign changes in f of x mean 2 or 0 positive real roots. Sorry about the horribleness of the writing, guys. Alright, f of negative x, we have 2x to the 4th plus x cubed minus 5x squared minus 2x plus 2. So we have, that's an equal sign. 2 sign changes. So we have 2 or 0 negative real roots. Okay, so our P's over Q's. Let's see, we've got plus minus 1 and plus minus 2 over plus minus 1 or plus minus 2, which gives us plus minus 1, plus minus 2, and plus minus 1/2. Okay, so let's just start testing. Let's test 1, and I think that's going to give us a 0. In fact, I know it is because I've already worked these out. So 2, 1, oops, negative 1, sorry. Negative 5, 2, and 2. So that gives us, when we do the 2. Okay, so if our g of x, our depressed equation, is 2x cubed plus x squared minus 4x minus 2, we can just test roots in there. So let's see, g of negative 1 is 1. That doesn't help us. G of 2 is 10. That doesn't help us. Remember, we need 0. G of negative 2 is negative 6. Wow, still no help. G of 1/2 is negative 3/2. 3 1/2. Still no help. And g of negative 1/2, we finally found one that's 0. So now we have to do synthetic division with a negative 1/2. Okay, we're going to use our depressed equation. So 2, 1, negative 4, negative 2. So bring down the 2. 2 times negative 1/2 is negative 1. Add. Anything times 0 is 0. So add. Negative 1/2 times negative 4 is a positive 2. Yay. And our depressed equation for this one is 2x squared minus 4. Now, this actually factors. So, if we take out a 2, we're left with x squared minus 2. And if we set that equal to 0, we get x squared minus 2 equals 0. So x squared equals 2. And by the square root property, we get x equals plus or minus the square root of 2. Now remember, square roots, as long as the negative is not inside the square root, are real numbers. So that means that f of x actually factors into x minus 1, x plus 1/2, x minus square root of 2, and x plus square root of 2. And remember, I said this term right here with the fraction could be written as 2x plus 1, but all the others would be the same. And on the test, I don't care which way you write it, of course, because you know I'm happy however. Okay, now there's one other thing I want to mention, which is not in this note sheet. Well, it is, but not very well. What if we had x cubed, shoot, that's a 3, guys, x cubed minus 2/3 x squared plus 8/3 x plus 2. And we wanted to factor that using the rational roots theorem. Well, the rational roots theorem says that all the coefficients, so the numbers in front of all the variables, have to be integers, meaning we can't have fractions. So in this case, we need to get rid of the fractions. And we're going to multiply both sides of the equation by 3, because that's the least common denominator, and we'll get rid of the fractions, right? So we have 3x cubed minus 2x squared plus 8x plus 6 equals 0. Now, we're going to use these numbers, our new coefficients, to get our possible p's and q's. If we did it from what we originally have, we would get p over q equals plus minus 1 and plus minus 2. Let's see what happens if we do it from our new equation after we got rid of the fractions. Then we would get p over q equals, let's see, we got plus minus 1, plus minus 2, plus minus 3, and plus minus 6 over plus minus 1 plus minus 3. So that gives us plus minus 1 plus minus 2 plus minus 3 and plus minus 6. Also plus minus 1/3 plus minus 2/3. And then 3 over 3 just gives us 1, which we've already covered, and 6 over 3 gives us 2, which we've already covered. But as you can see, there are a whole bunch of roots that we would have missed if we did not get rid of our fractions first. Now, when we go to test these, we do not plug them into the equation that we got them from. We go back and plug them into the original equation to do our factoring or find the roots or anything else. That's the only thing I wanted to mention extra because it's a little tricky. Okay, that's it for this one. Sorry it's so long.